The purpose of this video is to demonstrate a number of common problems and help you understand them and why they occurred. The first problem we're going to look at is having bad attitude data applied to your Sidescan. Typically, this could happen if you have an incorrect field mapping when you did the nav Injector Pro import. In this case, we have two sets of data. We have the bad lines, which have pitch and roll swapped. We have good lines, which have pitch and roll in the correct location. You recognize the geologic feature, and we're going to focus in this case on this little feature right in here. Now I've produced a mosaic using the swap pitch and roll and a mosaic using the good correct pitch and roll, and had both these plotted up in ArcGIS. Focusing on that feature that we just talked about, you can see in the good data with the correct pitch and roll, you have this geologic feature on the bottom, a little bit of a ridge here, possibly some sand waves here, and over multiple swaths, you have a fairly continuous feature. However, if you incorrectly map the pitch and roll, you notice this feature does not line up. You start to get gaps on the outer beams of the swath itself, and the feature looks very disjointed and smeared around. So, correct pitch and roll, swap pitch and roll. Another possible error you have is if you oversmooth the navigation and heading when you import the JSF file. What you see here are two sets of lines. I have a set of lines here that are oversmoothed, where we use the default 300 ping smoothing function, and that results in this path. Here you have the lines that use the 3 ping smoothing for the already processed navigation, and you have that on this portion. And as you can see, the 3 ping smoothing nicely preserved the AUV turn, where the 300 ping smoothing distorted both the track and the corners very badly. As you can imagine, this would mislocate, distort, and smear all of the Sidescan data within this region. So if you're seeing your corners when you look at the nav plot that have been totally eliminated and don't look real, there's a very good possibility you oversmooth the heading and the navigation when you imported the JSF. Another problem is that you might see distortions of your geologic features, both large scale and small scale, as well as bad orientation if you pick the incorrect UTM zone. In this case, we're going to focus on this geologic feature, which is correctly mapped in UTM zone 19 north for this data, and this feature here. Please notice the orientation. Now I've taken it in mosaic each of 3 different UTM projections of the same data. You have the geologic feature in 19 north, which is the correct orientation and the correct feature. However, if you look at it at 16 degrees north, you start to see that the overall geologic feature is starting to rotate counterclockwise, and that you have some distortions within the geologic features on the seafloor itself. To make it even worse, if we go to 9 degrees north, which is 10 UTM zones inaccurate, you'll notice the features rotated counterclockwise significantly, and this feature is starting to have mismatch and distortion within it. You'll also notice the main feature is starting to widening out. So again, correct UTM zone, incorrect UTM zone, 3 UTM zones off, 10 UTM zones off. Another problem you may notice in your mosaics are bad bottom text. In this case, here's the good data showing your geologic feature and fairly good lines. Now, if we turn on lines 16 and 12, which I have purposely messed up the bottom detect on, you can see how you have white gaps here on line 16 and some white gaps in here, some skips and some distortions. Go to the bottom track. You can see very quickly the bottom track here is messed up. Because you have this big gap where it doesn't match the bottom, this big gap matches this piece right here. And as you can see, your cursor actually moves when you're in the bottom of the text, showing you where things are. So we should go ahead and correct that. There we go. Now we'll save that, and you'll notice the gap over here goes away. Now let's look at line 16 directly by itself. As you can see, you have some large white gaps again. Go to the bottom track. You can see the bottom track is completely off. If we do a track adjust, save it, it goes ahead and corrects all the features in there. So if you have gaps and white marks that are too much along your nadir, you should go back and look at your bottom track to make sure it is accurate. The last common problem we'll look at is export resolution of the mosaic itself. Once you've done your work to create the individual mosaic within SonarWiz, go to Post-Processing, Export, Save Project as a Geo Image. At this point, you'll name your file, choose a GeoTIFF, typically 8-bit, and you need to specify the image resolution. This is critical. If you do 1 meter per pixel versus 0.1 meters per pixel, you get very different file sizes, resolution, etc. You need to consider the resolution of your sonar, the resolution the client needs, and the amount of file space. Now in this case, I've done a number of different options. We'll go over to ArcGIS, where I've imported 4 different GeoTIFFs at different resolutions. As you can see, we're focusing on our feature that has a sand channel and this slight geologic ridge. This image is the 0.1 meter image that we've been working with the entire time. However, I've actually created a 1 meter, half meter, 0.25 meter, and 0.1 meter GeoTIFF resolution. The one you see of that same feature, that 1 meter pixel resolution, is on the screen now. If you look at the half meter resolution, you get to see a little bit more of the feature and a little bit more detail. At a quarter meter, you're doing pretty good. You're actually seeing the feature and starting to see some of the sand waves. And at 0.1 meters, you're seeing fairly good resolution. So you need to consider what your client needs to see, what the sonar resolution of your data set is, so you can determine the best resolution you can export the mosaics at. Thank you. Now this concludes the Common Problems video.